Okay, so let's get on with the practical session. And by my calculations, we're about 15 minutes behind schedule, so that's not too bad. I've designed 3-hour practical sessions. Yesterday's practical session went longer. Today's will have to go a little bit shorter, but that's okay, it's not a problem. So what we're going to do today is continue building on the concepts from yesterday, and there's not so much you can do in terms of running a statistical test. Like essentially we ran a statistical test yesterday. If you remember, we went t.test and then put in our thing that we were interested in, which was this formula object, and that formula object was the weight of the deer as a function of the species of the deer, and that gave us an output, and that output was, if you recall, degrees of freedom, t statistic, the averages for the two species, and the p-value, and that's it. So you already know how to do what we just spent the morning talking about, really, if it's only the t-test that you're interested in. So we'll do a bit of that, but what's more important is that we'll also play around with data and look at models. And we're going to break the rules of the p-value a little bit in this process. So I'm sort of teaching you some bad habits. But the purpose of that is to explore something that's more useful and more interesting, which is distributions and what they do, and how we can use them in sort of understanding what's happened in our research. So today we're not just going to simulate our own data, we're going to play with some real data. And the way we're going to do that, there's a number of different ways we could have done this. I could have sort of sent out a CSV file, which is sort of like the Excel sheet that we used yesterday, that you ended up generating yesterday. And then everybody downloads the same file, or we could have found something online, or I could have generated something in advance and we could have pretended as though it was real data. But what I've decided to do is to get some real data from packages. And do you remember I told you yesterday when we were talking about programming concepts, we had the up on the screen we had the data concepts on the left and the programming concepts on the right. And we had, on the data concept side, we had variables, then we had arrays, then we had data frames, and so on. And on the other side we had a command, which is what you type in down here, a script, which is what you type in up here, a function, which is a script that takes an input and gives an output, and a package, which is a set of functions that hang together somewhere. And they hang together a place, for our intents and purposes, which is called CRAN, which is where all of the extended research-like stuff exists. So we're going to learn a concept now, and that concept is installing one of these packages. Yes?
Before we do that, I didn't close mine down from yesterday, but I would like to, so in this imaginary world where I have two separate R experiments running, how would I shut this down properly and then start from scratch on this new project?
Have you saved your script?
Yes, the way we did last.
So then you just save it, and you just, I'm not going to talk to you about workspaces or projects levels, that's sort of more organization. All I'm going to do is tell you about scripts. So if you save your script, that's your work. If you've got your script and your data, that's your work. And the results of your analysis you can always get by clicking a button and running your script again. But it's a very good question, very useful. So if you've got your script saved and it's somewhere you can find it, you can feel free to shut it down from yesterday and you can go back to it later and have a clean slate. You can also have parallel scripts running. Oh, sorry. Did you mean more practically? Where do you click? Yeah. But But you can also have parallel scripts running, so you'll notice here that I've got our script from yesterday. You've got tabs, just like your web browser and stuff like that. So I started a new one which I've called Untitled. We haven't called anything yet, I haven't saved it. So what we're going to do, first of all, is we're going to install a package. Now normally packages are full of functions and stuff like that implements different statistical models, that does different operations on things. And I said that we weren't going to go beyond the functions that are available in base R, and we're not. All we're going to use this package for is the data that it contains. And this allows you to see how it is to install a package should you need to do so later on. And it's the most efficient way you can get access to data through R. So I foresee that someone will have problems here. The most typical problem is in terms of allowance. What's it called? I'm getting a bit tired, so I'm going to lose words. Sorry? Administrator Radihiller. So you know how your computer has a C drive, but it also has a C drive which is on the home domain or whatever domain it's on, and when you go home you can't connect to the all drive and all of that sort of thing? That sort of thing can really mess up your R installation. So if you have problems, it's going to be because of that. I have certain packages that I still can't run because of that, because it's complicated to fix. But I think we'll be okay, at least in this context. So what we want to do then is we want to install a new package, and to do that we use a function. And that function is install packages. And that function has an input, and that input is just the name of the package that we want to install. And the name of the package that we want to install is a word, so it goes in quotes. And the package I want you to install is DS Labs, which is short for Data Science Labs.
Then again, if anybody has a problem, just either wave at me or put up the pink sticky note, and I'm happy to come.
But where does this live?
So this lives on a repository called CRAN. So R, your software, is uniquely linked to this server with a database. And on this server or database is an enormous, massive list of packages, which constitutes all the cutting edge knowledge of statistics in the world today, and stuff in textbooks. So people write their own packages for their textbooks. And then what you do is, you write a package and you submit it to the people who run CRAN, and they do peer review and see whether they accept it or not.
Okay. But you can also see in packages if you go to that lower right window.
Yeah, that's the packages that are available on your computer. What we're doing is we're installing one from CRAN.
Yeah, but after it's installed, you can see.
You can see it,
right?
yeah.
Because
Yeah.
where does it live?
Exactly.
So after you've
Oh yeah. Where does it live? Where does it live when you download
over
it?
there.
No, I
It's-
actually asked where is it going out to find it?
Yeah.
Okay.
And so where it lives when it comes onto computers in the same directory that all of the other R software is installed. Is the lighting okay here? Anya prefers the lighting on, I guess. Can you see the screen? It might just be my superstition that made me think that you couldn't see the screen. No, good. Everyone's happy. No, it's fine. I'm just trying to be democratic. We're in Denmark. We operate by consensus. It's because people are sort of squinting a lot, and so I just want to make sure that everything's visible. You can't turn this row off. It's like you can only turn this row off separately, but you're never going to project over here. So anyway. Okay. So has everybody installed the package?
Yep.
Okay, so if you want to know more about this package, there's a website. This is basically ran by people who are teaching a course similar to this one. And so they've got some data that they've downloaded from different places and collected in their own class, and they've put it into this data set for other teachers like me to use. And if you want to look up a little blog about this, I will send it around with my notes. It'll be in my notes. It's DS Labs. You can also search Google. So now you've installed the package in your computer. It exists in your computer now. So the problem is that there's only a finite number of words or finite number of letter combinations in the world, and a potentially infinite number of packages. And if you're talking a sort of a restricted domain like statistics, then a lot of people are going to write packages with the same sort of name. So you're going to get packages conflicting with one another and talking past one another, and that's going to happen anyway. So what R does is it prioritizes functions that have got the same name in different packages, according to, I think, Adela, the most recently activated package. How does that work? Name conflicts in packaging?
Yes, it will override, but it
Yeah.
will give you a flag. So
It'll tell you.
If you want to use the other one, you just specify the package.
Yeah.
With
And so what matters for our purposes here is that as soon as you install the package, it's not visible to R yet. You kind of have to turn it on. And the way you turn it on is you say, well, there's a certain library that I want to be using at the moment of packages. And that library includes this package I just installed.
You don't need the quotation marks.
No, I'm just being consistent because then I knew someone would say, why doesn't that have quotation marks? Sometimes you do, sometimes you don't, and it's arbitrary. So, okay, so now we've got that data set. Actually, it's more than one data set. It's a bunch of data sets. So I'll sort of, and we're gonna go through two different data sets from this package. Install problems.
So Josh, should it say what it says
Yes.
on your console?
So depending, you can say this warning is telling me that it was built under a different version
But
of
should
what I'm
it say
using.
something? Because on our computers it says nothing.
It could be that you don't have the version conflict that I have.
Okay.
So I'm running an older version of R, and they've made this package after the fact. So this is built under a newer version of R than what I'm running, which is usually not a problem. Okay, so I'll go on then. There's a number of data sets in here, and if you want to learn about what data sets are in here, you can just go to the website that I'll give you. For now, we will just go straight in and go to the heights data. And the heights data, you access by writing data heights. So now R is going to go and look for some data somewhere in its packages, and it will find one called heights in the DS Labs package that's active in your library.
So if you have that term in different packages, it comes up with both, or
It'll come up with the most recently uploaded one. And whenever a package comes up that has the same name as one that's already active, it'll tell you if it has a function or a data set that's got the same name. So that's the heights data.
So this is from yesterday.
No, this is from somebody did the same task in their class, and they've uploaded it in their package. So we're doing the same thing that we did yesterday, but we're not doing it by institute, we're doing it by gender, because that's the variable that they gave us. With all of the possibility of multiple genders and that sort of thing. Yeah?
How can you tell that you've received those data sets?
So it does this weird thing that I don't totally understand why it does it, but it's got heights over here, and it's got promise here. That's your data set here, so it's your values, it's in your workspace.
Yeah, I see that now.
Yeah.
Also, I wrote data
Yeah.
heights, but to type in library.
Oh, how do you-
I saw nothing.
How do you, oh no, you don't usually see. Oh, is it because it's because I saw something and you didn't? Or
Yeah.
yeah, so I got a warning, which was that this package was written in a more recent version of R than I'm currently running,
Okay.
and that version of R is the same one that you're running, so there's no reason to warn anybody.
Okay, so I'm actually not supposed to see.
No, you're not supposed to see.
receive this.
No, no, you don't get a warning. It just loads it up and says it's running.
Can't you see the packages?
If you wanted to see it, you can go see packages, and that'll show you what's loaded up. But it's not an error; it's just a warning. Okay. So let's look at heights and what's in heights.
Just click on it.
Well, what we can do is we can investigate the contents of heights in a similar way to what we did yesterday. Sorry? We go head. Do you remember this trick?
Why are you writing down there now?
No reason. Because of my habit.
So we get all the headlines with height.
We'll get all the headlines and we'll get the two variables that we've got, which are male and female.
Can I ask something? Why the heights now are not in a
Because now it's not a now it's a variable. Now it's an array, right? So remember yesterday we were using arrays, and so when we made a is equal to 1, 2, 3, 4, 5. A was an object that we could then go and access and use. And so as soon as we go data heights, what we're saying is we want something called heights in this package. We want to take it out of the package and put it in our workspace as an object that we can use. So that's why we don't have the thing anymore, because we want to do an operation on heights, and that operation is look at the headings. So again, that gives us the first 6 data points, so we can see what sort of data is there. We've got categorical data under sex and height in inches under height.
So
It's because it's American.
that's fine, but I was just thinking if there was one that's self-defined as
If there was somebody,
something different,
yes,
we would get that third in
yes,
category.
you would
in the
get
first
you would get a
six.
categorical. You get categorical. So just like yesterday when we had some people from DPU, that would be legitimate.
Yep.
So let's start to do stuff with this. Okay, so from the first, a question, audience participation. What's the first thing we should do from the lecture this morning? What was the first sort of data thing that we did today when we were talking?
Frequency.
Yeah, we should do a frequency. We should do histograms. So how do we do histograms? Did we do histograms yesterday? We did, didn't we? No. We may not have done histograms. We did box plots, we didn't do histograms. So how do you do a histogram? So what we want to do is draw a histogram. And do we want to draw a histogram of everybody? Or I guess we can. Why not start there? So let's do a histogram of heights. But we want to do everybody, and we want to do a specific thing with a specific array in the heights data frame. And that specific array is height. And the way that we do that is we use the dollar sign, if you recall. So the dollar sign is how you pick out a column in data frame. Can you remember that from yesterday?
But if I wanted to do the histogram only with height, I would just write height.
Only with heights? Let's see if that works.
Okay.
No, you get an error because you can't do a histogram with an entire data frame.
Okay.
You can only do a histogram on an array of numbers.
Okay.
And so we need to pick out the array of numbers that's in that data frame. And that array of numbers that's in the data frame is this list of heights. So that's why we need to go heights, and then that picks out the data frame object, and then we want to specify one of the columns, so we use a dollar sign, and the column we want to specify is height.
Can I ask?
Yep.
The first height, what is it then? The second is the column within.
Do you know what I'm going to do? Can someone give me a name for the data frame? I'm drawing a blank. So let's call the data frame something else, because I'm going to get questions about do you mean heights or height, and that's going to confuse anybody for the rest of the day. So let's call it dat, right? Is that okay? So here you learn how to rename a data frame. So we're making a new data frame. It's called dat, and that's just equal to the data frame that was called heights. So now we've got a data frame called dat, and that appears up here. And they're just the same thing. Okay, so then we won't have this problem. I mean the heights and the height in heights. And it's going to be horrible. Okay? Okay? So now we want to do a histogram. Let's go hist, data frame, and we're only interested in the height because you can't really do a histogram of gender here. It's not really the right thing to do. And how does that look? That'll give us a histogram. And height is one of those things that's normally distributed. So this is what we started the day off talking about. This is just the different heights that people have in this course, and there's 1,050. So these people have taught this course a lot of times, collected data from everybody every time. And about 70 inches seems to be the average, and it's about in the middle of the distribution, so this is normally distributed.
What is that in centimeters?
Times 3, roughly.
Wow.
No, that can't be right.
That can't be.
Isn't an inch 3 centimetres?
2.5.
2.5. Yeah. We're Australians, we round up. That's why Australian wine's got so much alcohol in it. Okay. So what else could we do? Well, we could look at we could make a histogram of the heights of the different genders. And nobody's reported third genders in this study, or genderqueer or non-binary or anything like that. So let's make 2 new histograms. And how do we do that? We go dat, height, and now we're going to do some indexing. Remember indexing from yesterday? Indexing is pointing. So we're going to point at the heights that are male or female. Doesn't really matter what you do first. So we're going back over some concepts from yesterday. Is that okay? So we remember what the double equals means? Double equals means that we're looking at sort of equivalence. We're not assigning here. We're looking at an existing relationship. And so read in sort of human words, this says, give us a histogram, which is a function, which has an input, which is those columns in height where sex is equal to female. And we see that that's normally distributed, and the average is a bit lower. So I can do the same thing for men. And hist is just like plot. It's a function that takes an input and gives you an output, and the output's a figure.
What does invalid number of breaks mean?
Invalid number of breaks means that your histogram isn't making bins in a sort of understandable way for some reason.
Same error message.
For the female?
Yeah. So it's probably a very number of groups.
Oh, yeah, just back there.
Yeah, that's what's great.
That one? No?
It's case sensitive.
Oh, you've got set, not sex. You've got that dot set.
Yeah. It's so, it does exactly what it says on the tin. So you can make the tin out. Tack again.
So it's very easy to make typos in R.
Yes, it is.
I'm sure we'll have a machine learning version of this that will correct all your typos for you at one stage, but not yet. So that's the male data set. And it's normally distributed and so on.
Very short. Yeah.
Okay. So what else did we do today? We did frequency distributions. Yeah, there's the somewhat shorter than Danish average, the American average. And probably younger too, they're probably all 19, 20. You can have a growth spurt around that age. So
The arrows.
we did the errors, yeah. So we calculated the parameters, right? So now we've got the whole distribution. We also calculated the parameters of the distribution. So that would be the means and the standard deviations. And we did that yesterday.
Oh, yeah, yeah.
So should I give you a class exercise to do that again today, since you already know how to make a mean table and a standard deviation table? I'm seeing some horrified looks. So we're still in the honeymoon hand-holding period then.
Yes.
Okay, so we're going to make something, we're going to make a new object. It's always a good idea to make a new object for this sort of thing. So let's call it mean table. There's a table of our means of the stuff that we're interested in. And can anybody remember the name of the function that we use to get the mean? No?
Aggregate.
Aggregate, exactly. Because that allows us to use our data frame and everything. So what do? We use a formula here, right? So our formula is height as a function of sex. The data we want to use is dat. And the function we want to use, and notice that I'm always looking at my notes because I never remember syntax, so if you forget syntax, don't feel bad. Is the mean. So that'll tell us if we type in down here, because we made an object. Remember, when you make an object, it doesn't give you the output. It says, when you're telling it to become an object, you're saying, here are, I want you to remember this thing. And the thing that I want you to remember in this case is an array of means. So we then have to ask R, well, what is that array of means and what's it look like? So men are a tiny bit taller.
It's really hard to read when it's highlighted.
Yeah.
Oh, sorry.
Thank you.
So that's our mean. And to get standard deviation, SD table. No, SD table. Yeah, call it whatever you want. SD table. That's what I'll call it.
Yeah, and then just instead of function mean, SD.
Exactly. Standard deviation table.
Yeah.
And then we have a look at that. And the standard deviation is about the same.
So how do you read this? Is this, I mean, okay, we're not at p-values.
No, we're not at p-values. We're only looking at the parameters of the distribution. So here, this is the spread of the distribution in inches, and for men and women, and it's about the same.
But could just hold on for a moment. When you see an ST value, what do you make out of it? I mean, in this, it's always in conjunction with your data, right?
Yeah.
So you have to look at the mean, and then the standard deviation is it big or small in this case?
It's always going to be in terms of your scale. So that's where you're going to get your intuitions from.
Okay.
So your standard deviation here is in inches. And if you had a standard deviation in inches for worms of 3 inches,
Yeah.
that'd be enormous variance. You'd be looking at all sorts of different lengths of worms, right?
Yeah.
But if you had a standard deviation of 3 for people in inches,
Yeah.
that wouldn't be so much.
Okay, I see.
So go back to this definition. The formula that we've got for that is what's the average distance of each data point to the mean.
Okay.
And the average distance of all the data points taken together to the mean for women and men is about 3 inches. So on average, it's not much. It's about 3 times 2.5
Okay.
centimeters. In the notes, I've got some. Oh, do you need help? Yeah. So in the notes, I've got some discussion of departures from normality, where I talk about something called the Shapiro-Wilks test. But I'm not going to do that now because I bring it up only to debunk it and say that it's not so useful. And that was more, if you hear people talking about normality and violations of normality and you shouldn't be using a t-test, you should be using some other test, you shouldn't be using an ANOVA, you should be using some other thing. Basically, take it with a grain of salt because most people don't realise what a violation of normality is, and it's something where there's no specific test that can tell you whether or not you violated normality. We think there's a statistical test that you can do to check, but it doesn't work. If it gets really big, everything's a violation of normality. If the number of subjects you've got is big, everything's a violation of normality. If the number of subjects that you've got is very small, nothing's a violation of normality for this particular test. So there's no real principled way of talking about violations of normality. Everything involves eyeballing some or other plot. So don't worry about violations of normality. Look at the exercises yourself. That would be the instruction. Okay. So we talked a lot about... Oh, is there anything I can help with? Okay. So we talked a lot about frequency distributions. And now we've tried playing with frequency distributions and looking at frequency distributions. And we've looked at the parameters of frequency distributions. What about probability distributions? Can we look at probability distributions and visualize probability distributions? We can. Do you remember when I said that we also call a probability distribution a probability density function? No? Okay. So this is something that statisticians call, for some reason they use the word density and say that here you've got your probability distribution. Here you've got your probability distribution and you've got an area under the curve of 1, and the statisticians say what happens as you go along the curve is the density of the area under the curve changes. I don't know why they call it density, but they do. So as you go up, the probability gets more dense. More dense, more dense, more dense, more dense, more dense, more dense. Less dense, less dense, less dense.
So the density is just like the amount of things that would be under the
Yes.
curve at that point.
Yes, exactly. If you want, you can think of it. Oh no, that's all you need to know. So I won't give you any more analogies because I'll just confuse you. So essentially what you're doing here is you're modelling the density of the probability at infinitesimally small time points. Okay? So that's called, also then, this curve is called a probability density function. Because it's a function that you use to generate probability values. Okay? So it takes as an input a mean and a standard deviation. It runs some math on it and it spits out this shape. Yeah?
And when it gets to the 0 axis here on the,
Yeah.
then it becomes more significant.
Don't worry about the 0 axis significant. This is just for any probability. So this is just, so all I want you to think of as is this is a probability distribution, and all a probability distribution is a straight line drawn over a frequency distribution. So what we're going to do is we're going to, the reason I bring up this word density is because we're going to use a function called density. And what I want you to conceptualize this function as doing is going one step beyond that function that I showed you before, which was called hist. So hist takes an input and spits out a histogram. What this does is it takes an input, makes a histogram, draws a probability density function over it, draws a probability distribution over it. So that's what density is going to do for you. Okay? So that's what we're going to do.
Could you increase your font by like 1 point at least? Because lots of people are having those sort of reading issues. So
Thank you very much.
global options in the session that should do it.
Oh, I just do view.
Even faster than
How's that? I can't go any further, unfortunately. Okay, so what we've got, we're going to have a function called density, which calculates the density for each score, and then we're going to plot the density. And that way we can plot the probability distributions. Okay? So we're going to do two things. First we're going to calculate densities, and then we're going to plot those densities that we calculated. So let's do that. So the first thing we need to do is calculate the density.
You're writing out a small, but that doesn't matter, even though it's a female, male.
Yeah, you can pick whatever. I'm using a convention, this is a programming convention called Camelback, where you use, when you stick two words together, when you capitalize the first word. So you can see that it's two words, so the first letter of the last word. You can also use snake case, which puts underscore on. Or you can do whatever you want.
There are no camels in Australia.
Sorry?
There are no camels in Australia, are there?
Yeah. Yeah. The desert's full of wild camels.
Okay.
Huh?
Nice. We have one.
What would be the probability of meeting a camel? Oh yeah.
So we're going to calculate the density. Density is just a function that takes in an input and spits out densities. Dat height where dat equals okay, so that's warnings that I don't usually get. We'll leave that for now and see what happens. And then do the same for male. And now we want to plot our densities. Oh, sorry.
Sorry, I'm not so fast.
No, that's fine. It's just because I didn't realize the top line had disappeared. And what we're going to try to do is something a little bit more advanced. Is we're going to plot the plot, right? So we're going to make the plot the way that we normally would. And then we're going to plot one gender. And instead of doing like we did before, where we make another new plot of the other gender, so we have to click back between the two to see the difference.